Hey there, kiddos. This is lesson 28 in Module 2. We are getting so close to the end. It's very exciting. But also at the same time, when we get close to the end, the program will give you lots of word problems. In fact, this lesson is only word problems. So we're going to take the skills that we've been working on for weeks now, division, multiplication, adding, subtracting, all that stuff, and we're going to make sense of it with word problems. So let's get started. There are only 4, but man, they are multi-step, seriously challenging. So let's jump in. Also, click subscribe and you will be notified when I upload a new video, and you can come back and find more videos for Eureka Math. And sometimes I'll be reading books and stuff like that. So it's all good. Come back again. So Ava is saving for a new computer that costs $1,218. She has already saved half the money. Great, that's an important word. Ava earns $14 per hour. How many hours must Ava work in order to save the rest of the money? So when you have a problem like this, you need to use the strategy that we've been talking about for a while. Read, draw, write. Now that we read it, let's draw what we know. Use a tape diagram to kind of show the numbers that you have, and then it'll also illustrate what you don't have. Oh, and it'll also get blurry sometimes when it's out of focus. So anyway, it will focus, I promise. See, it's coming. It's coming. Still not there. Oh, welcome back. So Ava has $1,218 as her total expense that she has to prepare for. She's already saved half the money. Bravo. So what is half? We don't have any other numbers. All we know is that she earns $14 per hour. So how do you find half of a number? Well, you start out by doing division. So 1,218 divided by 2 would give us half. Now, 1 is not divisible by 2, but 12 is. Nice and even. 6 times 2. Write the steps of the division family. Divide, multiply, subtract, compare, bring down if you need it. 12 minus 12 is 0. Now, when there's nothing left over, but I still have this digit that comes down, 1 comes down, and it is not divisible by 2. Hold this spot with a 0. You can't forget to put a digit up there in the quotient when 1 is not divisible by 2, because this is actually going to give you the opportunity to regroup this 1 in the tens place with the 8 ones that will come down next. Now I have 18 ones that are divisible by 2 9 times. 9 times 2 is 18, and now we've used up all of the $1,218. So each of these represents half at $609. Okay, so let's work on this part. So Ava earns $14 per hour. How many hours must she work in order to save the rest of the money? So if she works and makes $14 per hour, that's money, and then she works another hour and she gets another $14, and we have 1, 2, ... How, well, we know this is 14. How many question mark hours right here will she have to work in order to save the rest? Well, what we do know is we know the total and we know the hourly rate. So let's take our 609 and divide it by 14. So the first step divides it into the 2. The second step, we're only dealing with this, and we want to break it into these $14 increments. So this is money, and now we're going to get hours as our answer. So let's start dividing. 6 is not divisible by 14, but 60 is. If I had 15, I know that 15 plus 15 is 30, and then 2 of those would make 60. So if I guess 4, then I'd be pretty safe because 14 is less than 15. 4 times 4, 16, and then 4 times 1 is 4, plus 1 is 5. So I am safe here with only 4 left over. And I do my quick compare. This is less than 14, so move on, bring down the 9. So 49 divisible or divided by 14. And if 4 times 14 was 56, and then I'm looking and I'm saying, well, this is a little bit less, so I'm going to use a 3 because it's very close. 3 times 4 is 12, carry the 1. 3 times 1 is 3, plus 1 is 4. And we have a number that is just a little bit less than what we had before. 9 minus 2 is 7, so it's 7 less. But remember the strategy that we've been using lately. If I have a remainder, I can continue dividing. I would like to know exactly how many hours. Annex a decimal, decimal down, decimal up, and a 0. And let's do place value position by place value position to see exactly how many hours. Now I have 70 divided by 14. So if I had the 4 times 14 was 56, and that's pretty close to 70. What if I have a 5 here? 5 times 4 is 20. 5 times 1 is 5 plus 2 is 7. Look at that. So using the other little products that you got by multiplying your quotient number by the divisor, use those to help you hop up and down and figure out what to put in your quotient. 70 minus 70 tenths, and that's 0. So we have exactly 43 and a half hours. That would be the time that Ava has to work in order to save the rest of the money. So let's label our answer. Ava must work 43.5 hours to save the money. So this one wasn't too bad, only 2 steps and a little tape diagram. And if you wanted to put, you could put 43 and a half because 5/10 is equal to a half. But we don't really have to play around with that too much. Let's do the next one and you'll see how kind of complicated these can be. I'll fold this back so you guys can have a better view. Michael has a collection of 1,404 sports cards. He hopes to sell the collection in packs of 36 cards. Okay, so underline and make note of all the important information. And he hopes to make this much money, $633.75 when all the packs are sold. If each pack is priced the same, okay, that's an important piece of information. How much should Michael charge per pack? So if we look at this again in terms of a tape diagram, okay, we've got Michael with all of his 1,404 cards, and he hopes to sell them in packs of 36, so we know that these packs of 36, it would be 36, 36, dot, 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 all the way till we're 1, 2, down here at the end, okay? So we've got some missing information here. And when you know the total and you know part of this, but you don't know the other, these tape diagrams are like a part to whole relationship. So let's take our 36 for the first step per pack and divide the 1,404, all the cards, divided by the 36 per pack. So let's see how many packs there are. So 1 is not divisible, 14 is not divisible, but 140 is divisible by 36. So if I had 40, let's just say, 4, 8, 12, I could guess 3. And I actually have a little bit less. I could try 4, but 4 times 6 would be 24. And then 4 times 3 is 12. Oops, and I would be over because at 12 plus 2 is 14, and I would have too much here. So let's use 3. 3 times 6 is 18. 3 times 3 is 9 plus 1 is 10. So we have to subtract and find the difference. Take 1 and give 10. Subtract 10 minus 8 and get 2, and the 3 minus 0, we get 3. Now 32 is a pretty big remainder, but it's still less than 36, so I can continue to bring down. Now if I have 324, and 32 is pretty big, I could guess a large number up here. I could start with 9. And also thinking about 9 times 30, well, that's the 27. And so we want to be pretty close without going over. So 9 times 6, that was just in your head, remember. I wish I had a different number. 9 times 6, 54. Carry the 5. And then 27, 28, 29, 30, 32. And look at that. The 9 got us right where we needed to go. So 39 packs would go right here. So fill in instead of a question mark. Now we know there are 39 packs of 36 cards each, which would make up the 1,404 cards. Okay, now what do we do with this information? He hopes to sell the collection, these 39 packs of 36 cards, and make $633.75 when all the packs are sold. If each pack is priced the same, how much should Michael charge per pack? So if I have my picture and my numbers and they're all filled in, now I need to move on to the money. So I could make another tape diagram to show if I have $633.75 as all the money that he wants to make when everything is sold, and I know that there are 39 packs, I can do 1, 2, 39. Okay, so then what would be the price? And that's what we don't know this time. But see, look, when you have this part-to-whole relationship, it starts to make things clear as to what you're going to do. So let's take our 39. Actually, I'm going to move it over a wee bit so I can have a little bit more space. 39. And the 6.3375. Decimal up, do that right away. Now, 39 is just about 40. And so I'm using about 40. Doesn't work with 6, but yes, it does with 63, but only one time. 1 times 39, 39. Do your subtraction. Remember your steps of the division family. 3 minus 9 you can't do, so take 1 and give 10. The difference between 9 and 13, 4. The difference between 5 and 3, 2. Compare your leftovers. You've got your 24 here to 39. This is less. Move on. Bring down the 3. Now I have 243 divided by 39, which is really divided by about 4 because of the 40. Remember, I wish I had 40 because 4 would go into 24 about 6 times. Use the 6. 6 times 9, 54. Carry the 5. And then 18, 19, 20, 21, 22, 23. So we have 234. We have to find the difference between 234 and 243. If it was 244, it'd be 10, but it's not. It's 1 less. So that's 9. Bring down the 7. Keep things lined up neatly, please. 97 now divided by 39. If this is really almost 40, then 2 40s would be 80. So we're really close. 2 times 9, 18. 2 times 3, 6 plus 1 is 7. And you can use the standard algorithm or find the difference between these two numbers. And it's really close to 98. So if I did 78, 88, 98, that'd be 20. But it's 1 less than that. So it's actually 19. Or use the standard algorithm, take 1 and give 10. 19 is less than 39, so bring down that 5. Now I have 195 divided by 39, which is really close to 40, which if I had 4 times a number, I could get 4 for 16, but I actually have less. I could try 5, and let's see what happens. 5 times 9 is 45. Carry the 4. 5 times 3 is 15, plus 4 is 19. Ending out with a 0. So $16.25 is the price that we should, that he, Michael, should label for each of the packs of cards. So let's do right here, $16.25 is a good price for each pack. Okay, and that will help him make all the money he wants when he sells his card collection. All right, ooh, yeah, see what I mean by these are pretty challenging? Many steps here. Hang in there. Hang in there. I think last year's video I was talking about fifth graders crying, and if it was me and I was 10, I would definitely not be doing well with this lesson. All right, let's move on. Gymnasium, yes, for real, is building a treehouse for his 2 daughters. He cuts 12 pieces of wood from a board that is 128 inches long. That's the whole board. He cuts 5 pieces that measure 15 7/75 inches. That's important. And 7 pieces evenly from what is left, and that's what we don't know. Now, this is a whole problem right here, okay? There's a lot of work packed into those first couple of sentences. Now there's more, so let's kind of put this off till later, but we'll get there. Jim calculates that due to the width of his cutting blade, he will lose a total of 2 inches of wood after making all the cuts. What is the length of each of the 7 pieces? This is our question that goes up to this question mark. But here is another bit of information that we have to start with, okay? We have to start by talking about the 2 inches of wood that's going to become sawdust, okay? So if you've ever seen somebody cutting wood with this circular blade, it goes zzz, and there's wood bits flying everywhere. So you can't count on those little bits to be in your final pieces because it's shaving them off. So he's calculating about 2 inches right from the beginning. And this is important because it's going to impact our step 1. So first of all, make a tape diagram. Label it 128 inches because that's what we start with, okay? Right from the beginning, he loses 2 inches in dust, okay? So we're going to take that 128 and we're going to subtract 2 inches right away to end up with 126 inches, and that's really what we have to work with for the whole problem, okay? Because you have to take off the dust. That won't be on any of the cuts. Now he does cut 5 pieces that measure 15 7/75, so let's do 5 of those. 1, 2, 3, 4, 5. Okay, so all this amounts to 15.75 each. Let's just label that 15.75. And then that's going to be here and here and here and here. I wonder what the total is. I guess we could figure it out. And then 7 pieces evenly from what is left. So this we will get to in a minute. First of all, let's figure out how much was taken off with these 5 pieces at 15 7/75. So it sounds like repeated addition. It is, but instead of doing repeated addition, you should use multiplication. 5 times 5, 25. 5 times 7, 35. 36, 37. 5 times 5 is 25, plus 3 is 28. And then 5 plus 2 is 7. If I have hundredths times ones, I would get hundredths. So the total amount of inches for these pieces here, okay, all that is going to be 78 7/75 inches. So what's left? Okay, let's find out. Take your 126 that was the hole that was left after the sawdust. So if this is step 1 and this is step 2, step 3 would be to take the 126 and remove 78.75. Now, where's the decimal in this number, 126? It's here. When you subtract, you have to line up by the decimal. So put 78.75. Now we're going to subtract this. But what am I pulling 75 from? I'm pulling it from zeros, okay? Fill in with zeros so you can subtract from them. We have to go over to the 6 ones in order to get something. So take 1 and give 10 here. but there's still nothing here. That's okay. Take 1 and give 10 here. You always take 1 and give 10 at the very next place value position. Now I have 10 minus 5, and I get 5. 9 minus 7, that's all ready to go, and I get 2. Decimal down. And then 5 minus 8, oh, can't do it. That's okay. Don't worry. Take 1, give 10. And then the difference between 15 and 8 is 7. And 11, take 1, give 10. And so you should end up with 47 and 25/100 inches that are now left after the 126 takes off the 78, okay? So out of all this that's left, we have 47 and 25/100 inches, okay? So this part is 47.25. Now go back to the problem. So much checking. He cuts 5 pieces that measure this and 7 pieces from what is left. 7 pieces from what is left. Okay? What is the length of each of the 7 pieces? Do you know what you should do now? Yes. Let's take this and split it into 7 pieces. Okay, so it's division, decimal up. Isn't this crazy? This is a 5th grade math problem? I don't think so. All right, so 47 divided by 7. I know my times table is 6 times 7 is 42. I want to get as close as I can without going over. 5 is left. It's less than 7. Bring down the 2. 52 divided by 7. I know my times table. 7 times 7 is 49. Subtract and get 3. Bring down. And I have 35 divided by 7 for an even 5. And then I subtract and get 0. So finally, we're going to label that inches, length of each of the 7 pieces is 6.75 inches. Okay, there you go. Big answer. And now we are on to the last one. Okay, the bricks and sticks problem. A load of bricks is twice as heavy as a load of sticks. The total weight of 4 loads of bricks and 4 loads of sticks is 771 kilograms. What is the total weight of only 1 load of bricks and 3 loads of sticks? So let's use a tape diagram. It will help you. All we know here is that we have the bricks and the sticks. Bricks are twice as heavy as sticks. So let's start out with a load of sticks and a load of bricks. Bricks are twice as heavy. So when you make your picture, your tape diagram, you're going to have sticks and bricks. Bricks are twice what the sticks are, okay? Whatever they are. The total weight of 4 loads of bricks and 4 loads of sticks is 771. So let's make 2, 3, 4. And if this is 1 load, it would have to be 2, 3, 4. Okay? So notice that I'm creating all these equal size pieces. That figures very importantly into getting the 771 shared evenly, okay? So now that I have gone through all this and I set everything up, we have to figure out what each of these is. No problem. How many of these are there? 1, 2, 3, 4. That makes 8, 9, 10, 11, 12. So if I have a total of 12 pieces and 771 is my total, then take the 771 and divide by 12. 7 is not divisible by 12, but 77 is. If you know your 12s, you might guess 6, and that could get you pretty close. 6 times 2. 12, 6 times 1 is 6 plus 1 is 7. 7 minus 2 is 5. That's less, so bring down the 1. 51, I know that 12 times 4 is 48. The difference is 3. I also know that I can annex a decimal and a 0 and continue dividing so that I can get an exact answer. 30 divided by 12, I can put 2, but I will still have something left over. I will have 6. But I know 6 is the first digit in 60, which I will then bring down this 0. And 60 is 12 times 5. 5 times 12, 60, ending with 0. So if one of them is 64 and 25 hundredths kilograms, and that is per piece, then I have some figuring to do to get the multiple loads, okay? So let's take and find what that would be for double. You can add them together. Let's say we do the 6425 times 2 so that we could find one load of bricks right here. 5 times 2, 10. 2 times 2, 4 plus 1 is 5. 4 times 2 is 8. 2 times 6 is 12. Hundredths times 1 is hundredths. And that's going to be kilograms for one load of bricks. But that's not the final answer. We have to have 3 loads of sticks. So take your 64 and 25 hundredths and multiply by 3 to get our 3 loads of sticks. 5 times 3, 15. 2 times 3, 6. Plus 1 is 7. Then we have 12, 18, 19. Hundredths times 1's hundredths. And this is for 3 sticks loads. So that's one little solution in itself. And then we have to put these things together. So we end up with 128.50 and 192.75. This is a 5th grade math problem. Right. 0 plus 5 is 5. 7 plus 5 is 12. Carry the 1. 8, 9, 10, 11. 9, 10, 11, 12, and 3. Final answer. Don't forget to click subscribe and come back again. 321.25 kilograms for all the things. One load of bricks and 3 loads of sticks. Huzzah! We made it. Congratulations. I'll see you on the next video. Bye for now.